Grade 9 learners, let's look at the rate of what? I like to focus on this one more because now this is the real test for proportions, for compound proportions. Rate of work for compound proportions may not be that new. Rates of work. Rates of work. Now, rate of work is not that new. We handled it in grade 8. But for grade 9, we are focusing on compound proportions. So like we are comparing more than two ratios or more than two events. Okay. In grade 9, rest of work help us to figure out how long attacks will take when people work together or when conditions like maybe the number of workers change. So we are going to use the compound proportions method to help us to find the rate of works. Let me mention that there are several ways to solve problems involving rate of works. And you can use a unitary. You can use unitary method. The unitary method. You can use the unitary method to solve rates of works. This method usually involves finding what one person does. Or you can also use the formula method. I don't know if they're the same, the formula method and the unitary method. However, to make maths more interesting, it's good just to use common sense when calculating rates of work. Only the ratio method that can help us to use the common sense. I would like us to focus more on the ratio method. The ratio method. The ratio method is the easiest, or I can say that the ratio method makes much sense. The ratio methods, it makes much sense. So the ratio method is often the easiest and most reliable because it follows a simple logic. The logic of the ratio method is that if this increases, we'll be asking ourselves that if this variable increases, what will happen to the other variable? Yeah, if this variable increases, what will happen to the comparable variable? So we are going to focus on um, comparing. Our focus will be on whether the results should be bigger or smaller. Yeah, like we don't have to memorize which variable is inverse or which variable is indirect. Yeah, we don't have to memorize all those things. We'll simply be using our common sense to pick which number goes on top of the fraction. Yeah, which number goes on the top of fractions. Yeah, that's it. So, for example, For example, let's look at some situations. Let's look at some situations, and let's look at for some situations that we can apply these the ratio method to help us to solve the rest of work. For example, if we have more workers, a situation that you have more workers, more more workers. If you have more workers to do any kind of job, maybe stealing a land or sewing uniforms or cooking or constructing a road, you know, if you have more workers, what are we supposed to expect on the number of days, on the number of days that we take to complete a certain task? If we have more workers, we know that the time that they will take to complete a certain task, the time that they will take to complete a certain task will decrease. Yeah. If you have more workers, time taken or time needed, time needed will decrease. Yeah, time needed will decrease, and that's common sense. So when the time needed decreases, we will use a decreasing ratio. Yeah, a decreasing ratio, and the decreasing ratio is a proper fraction. Yeah, it's a proper fraction. It's a proper fraction. What I mean by a proper fraction is that we'll have a smaller number or a bigger number. Yeah, we'll have a smaller number or a bigger number. That is when we have more workers. When you have more workers, they will require less time to complete any job. That's one of the situation. But think of another situation. Think of this situation that we have more work. We have more work to be done. What will happen to time when you have more work to be done? We have more work to be done. Maybe you have more assignment to do. What will happen to the time? Yeah. If you had like uh if you have like two two questions for your homework, and then the teacher had the one question, so you have three questions. So let's say more work. Yeah, you have more work to do. What will happen to time? It's common sense that time taken will increase. Yeah, the time needed will increase. The time needed will increase. And when the time increases, we are going to use improper fraction. We are going to use improper fraction. And why are we using improper fraction? To show that it's an increasing ratio. Yeah, we know that increasing ratios are always in improper fractions. So when you have more work, you'll need more time. You need more time to complete that work. And that's why for compound proportions, when you have more work, you're expected to use the increasing ratio. And the increasing ratio is an improper fraction, that is a big number of a small number. Let's look for another scenario. The last scenario, just for illustration. Faster speed. Faster speed. Faster speed. Um, if you're driving a car, or maybe if you're running, or whatever you're doing, if you start doing whatever you're doing at a faster speed, what will happen to time? If you increase the speed, what will happen to time? If you increase the speed, you are solving your mathematical problems, if you increase your speed, it's obvious, it's common sense that the time taken will reduce. It's common sense that the time the time needed will reduce. The time we needed will reduce because of increased the speed. Yeah, if it were a vehicle, it will be maybe if you are driving, if someone was driving at let's say 40 kilometers per hour, and then that person increases to maybe 70 or 80 kilometers per hour, the travel time will decrease. Yeah, that's using common sense. The time needed will decrease. And what do we do when the time decreases? When there's a decreases, when there's a decrease on the unknown, what do? We use a proper fraction. We use a proper fraction. And as I said, a proper fraction illustrates that there's a decrease. It's a decreasing ratio. A proper fraction is a decreasing ratio. So when the speed increases, the time taken will decrease. And it's only logical. It's only a common sense that we should represent that change with a decreasing ratio. We should represent that change with a proper fraction. We should represent that change with a small number up over a big number down. That is what we call that's a proper fraction. So I think that makes sense. It makes sense more than a unitary method. It makes sense more than using a formula. Yeah, ratio method is the best because the easiest. It just requires you to use common sense. It just requires you to think a little bit, and you know how to calculate rates of work. And we'll look for some example to see how we change decreasing and increasing ratios to find the rates of work. Our first example, is the two pipes B and Q are used to fill a community tank in Machakos. Pipe B can fill the tank in 10 hours, while pipe Q can fill it in 15 hours. If both pipes are open at the same time, how many hours will it take to fill the tank? Now, this is so easy. Pipe B, let's say pipe B can fill the tank in 10 hours. It fills the tank in 10 hours. And then you have pipe Q filling the same tank in 15 hours. So how are we going to handle this? We are going to find the the level, the amount of water, or not the amount of water, the volume of water that will be filled in 1 hour. Yeah, in 1 hour. If in 10 hours it filled the whole tank. In 10 hours, this is um whole. That's the whole tank. 10 hours is the whole tank. What about in 1 hour? In 1 hour, in 1 hour, let's write it well. In 1 hour, we'll have pipe P will fill 1 over 10. In 1 hour, it will be 1 over 10. You see, in 10 hours, it fills the whole tank. And in fraction 1 is just a whole. So in 10 hours, it will fill 1 over 10 of that tank. 1 over 10 of that tank. Now, this is the volume that will be filled in 1 hour. For Q, the volume that it will fill in 1 hour is 1 over 15. Those are for 1 hour. Now, if they are open together at the same time, the volume that they will fill, both of them, the volume that they fill at 1 hour is the addition of 1 over 10 plus 1 over 15. That's the volume that both pipes will fill in 1 hour. So when you add 1 over 10, 1 over 10 plus 1 over 15, you lose your LCM, which is 30. LCM here is 30. And then 10 goes to 30 3 times. And then 15 goes to 32 times. And so we have 3 plus 5 is 5 over 30. That is 1 hour. In 1 hour, these two pipes will fill 5 over 30. 5 over 30 is the same as 5 goes here 1 and 5 goes here 6. So in 1 hour, they will fill 1 over 6 of the tank. 1 over 6 of the tank. 1 over 6 of the tank. So let's say that in 1 hour, it will fill 1 over 6 of the tank. Then we want to know the time that they will take to fill the whole tank. That is 1. 1 represents the whole tank. Yeah, 1 hour, it fills 1 over 6. So how long will it take to fill, or how many hours will it take to fill the tank, not the whole tank? Now in this case, we just cross multiply. This will be 1 times 1, and 1 times 1, and then you divide by 1 over 6 over 1 over 6. So what do? You'll have 1 over 1 over 6. So if you divide 1 over 1 over 6, you'll reciprocate this one, and you'll have 1 times 6 over 1, which will give you 6 hours, which will give you 6. And that is 6 hours. So let's look at the second example. The second example is that in an estate in Githurai, a community sim tank supplies water to residents. When empty, the inlet pipe from the Nairobi Water Company can fill the tank in 12 minutes. That's the inlet takes 12 minutes. But due to a leak at the bottom, a full tank could empty itself in 18 minutes if the inlet pipe were closed. If the tank is initially empty and the caretaker opens the inlet pipe without repairing the leak, how long will it take for the tank to become full? Now this is so easy. It's so easy. We can find our fill rate. The tanks that fill it, our fill rate will be 1 over 12, 1 over 12 per minute. It takes 12 minutes to fill, 12 minutes to fill the tank. Yeah, if you take 12 minutes to fill the tank, this is 1 over 12 of the tank. Like what we're doing is that it takes 12 minutes to fill the whole tank. Then what about 1 minute? What about 1 minute? So you cross multiply. This is 1 times 1, and then you'll have 12 here. That's where we are getting 1 over 12. So if you take 12 minutes to fill the tank, as a fraction, the whole tank represents 1. So 12 minutes represent filling the tank. That 12 minutes will be 1. And then we need to find the rate. And so that will be for 1 minute, it will fill 1 over 12 for the tank. 1 over 12 for the tank. In 1 minute, it fills 1 over 12 for the tank. Now, we have a leak rate. We have a leak rate here. It leaks. It empties itself in 12 minutes. That's the leak is in 18 minutes. So our leak rate will be 1 over 18. And where do we get 1 over 18? Yeah, 18 minutes represent 1. So in 1 minute, we'll have, we say that 18 minutes represent 1. That's the whole of the tank. Now you'll ask ourselves, what about 1 minute? And then you'll cross multiply. That's 1 times 1 over 18. That's what difference is giving us 1 over 18. 1 over 18. So in a minute, the leak will be 1 over 18 of the tank. But now if they're running together, if the fill and the leak are running together, we are going to have the net fill rate. Let's call it the net fill rate. The net fill rate will be 1 over 12, which is the fill, and then we have the leak, which is 1 over 18. That is for 1 minute. It's for 1 minute. So you'll find the LCM and you'll subtract. If you find the LCM and subtract, you'll find the answer will be 1 over 36. 1 over 36. So that is for 1 minute. 1 over 36 is for 1 minute. Now, 1 over 36. What's the meaning of this 136? 1 minute, 1 over 36 of the tank will be full. 1 over 36 of the tank will be full. Now, how long will it take for the tank to become full? In 1 minute is 1 over 36. So how many minutes or how many hours will it take it to become full? To be full, we need 1. 1 represent full. Yeah. 1 represent a whole part. So 1 minute is 1 over 36 of the tank. Now full tank is being represented by 1. We are using 1 to represent the full tank. Now we just cross multiply. We'll just 1 times 1 over 36. So this will be 1 times 1 over 1 over 36. This will be 1 over 1 over 36. And this will be the same as reciprocating. It will be 1 times 36 over 1, which will give us 36. So it will be 36 minutes. It will be 36 minutes. Isn't that the third example? At a school in Kisumu, 8 students can weed a vegetable garden in 6 hours. If the school needs the garden weeded in only 4 hours, how many extra students must be recruited to join the regional group, assuming they all work at the same rate? So at a school in Kisumu, we have these students. You know the students. You have 8 students. They can weed a vegetable garden in 6 hours. And then you have hours. Yes, we have 6 hours. If the school needs the garden weeded in only 4 hours, how many extra students must be recruited to the original? extra students. So let's use our common sense here. 8 students take 6 hours. What about how about 4 hours? If 8 students are taking 6 hours for the work to be completed in 4 hours, do we need more students or less students? The answer is we need more students. We need more students to take less hours. So what we are going to do is we are going to multiply 8 times increasing fraction. Yeah, times increasing ratio. That is times in improper fraction. So we're going to find 8 times 6 over 4. 8 times 6 over 4, which is going to give us here is 1, here is 2, and 6 times 2 is 12. So we'll need 12 students, but we already have 8 students. Yeah. How many extra students must be recruited? You already have 8 students and we need 12. So the extra will be 12 minus 8, which will be 4. Yeah, we'll need 4 extra, 4 extra students. Yeah, we'll need 4 extra students. Let's look at number 4. Number 4, a construction company finds that 15 workers can pave 3 kilometers of a road in 12 days. How many days will it take 20 workers to pave 5 kilometers of the same road? So in this case, we have workers. And how many workers do we have? 15. These are 15 workers, and they can pave 3 kilometers of road into a flat. Let's just write here road. Road. Now the distance of the road. You have 3 kilometers, and let's have the time, which is days. 12 days. 12 days. And now, how many days will take 20 workers? We have 20 workers to pave 5 kilometers road. Now, this is interesting. We are going to use the ratio method to solve this one because the ratio method is easy. It just requires to use common sense. And let me demonstrate how we're going to use it. We are going to first we are going to compare the known to unknown, known to unknown. So our first step, we can start with any, but in this case, let's start with workers. To start with workers, let's assume that you don't have the roads. We want to compare workers and days. That's why I'm ignoring the road for now. Let's compare workers and days. Now, if 15 workers, if that company has 15 workers, the 15 workers will complete that job in 12 days. 15 workers will complete that job in 12 days. What about 20 workers? If 15 workers can complete it in 12 days, what about 20 workers? Now, common sense tells us that 20 workers will do it faster. Yeah, 20 workers will do it faster. So we are going to have a lesser number of days. So we are supposed to use a decreasing ratio. We are supposed to use a decreasing ratio so that we have fewer number of days. Yeah, so the decreasing ratio in this case will be a proper fraction, which will be 15 over 20. We'll have 15 over 20, then let's write here, multiply. Now let's go to the next one. We are done with workers. Now let's compare them. the distance and the days. The distance and the days. Now, 3 kilometers. 3 kilometers requires 12 days. 3 kilometers to construct 3 kilometers, you require 12 days. What about 5 kilometers? Do you need more number of days or less number of days? Common sense. Our common sense shows us that when we have 3 kilometers to contract this for 12 days, when we have 5 kilometers, we'll need more days. We'll need more days. So if you'll need more days, we're going to use an increasing ratio. An increasing ratio is an improper fraction. So we are going to write 5 over 3. 5 over 3 so that we have more days. And now we have our 15 over 20 times 5 over 3. And then now we can multiply it by 12. I hope I'm clear by there. We know how we have found 15 over 20 and how we have found 5 over 3. And then now we can multiply directly. Now let's substitute, or let's start by 3. Yeah, 3 here is 1, 3 here is 4, 5 here, 5 here is 1, 5 here is 4, and then 4 here is 1, and 4 here is 1. And down here we have 1 times 1 is 1, and up here we have 15 times 1 times 1 is 15. So our answer is 15 days. So our answer is 15 days. We write here 15. Our answer is 15 days. For calculating rate of work, just use common sense. It's not difficult. Just use your common sense. It's not difficult. Let's consider the last example. Our last example on the rate of works. In a workshop, 6 tailors can sew 24 school uniforms in 4 days. If the workshop receive an urgent order for 90 uniforms to be completed in 6 days, how many tailors in total will be needed to meet this deadline? Now, in this workshop, we have tailors. We have tailors and we have uniforms. And we have days. Now, we have 6 tailors. And we have 24 uniforms. And we have 4 days. And then there's an urgent order of 90 uniforms to be completed in 6 days. And now we need how many tailors? We need to find out the number of tailors needed to meet this deadline. It's time now to apply our common sense. We'll be comparing the known variables with the unknown. So we have 6 here. The first thing is we have 6. Then times. Now we want to know if we'll keep this one as 24 over 90 or 90 over 24. So let's cite this one. Let's ignore this one for y and compare these ones. Now 6 tailors. For 24 uniforms, we need 6 tailors. For 24 uniforms, we need 6 tailors. What about 90 uniforms? What about 90 uniforms? Common sense, common sense, common sense. 90 uniforms will need more tailors. For 90 uniform, you will need more tailors. Because 24 uniforms, we just need 6 tailors. Yeah, like 6 tailors can sew 24 uniforms. How many tailors will sew 90 uniforms? We need more tailors. So if we need more tailors, we need to increase. We need to increase this ratio. We need to increase this ratio. And when we increase ratio, we write it as an improper fraction. So in this case, we're going to have 90 over 24, which means if we expected fewer tailors, we could have written as 20 over 90. But since we need more tailors, we are writing it as an improper fraction to illustrate an increasing ratio. Now let's go to the next one. This is a multiplication. Now we are done with the uniforms. Now let's compare days and tailors. Now, if you have six tailors, you will take 4 days. 6 tailors will take 4 days. So how many tailors do we need to take 6 days? Yeah, 6 days. Now, common sense. 6 tailors take 4 days. How many tailors will take 6 days? It's common sense that if you want to take more days, then you'll have to decrease the number of tailors. So we are expecting fewer tailors to take more days and more tailors to take less days. So since we have more days here, we expect the number of tailors to decrease. And when we are decreasing the rate of works, we use a decreasing ratio. And we know that a decreasing ratio is a proper fraction. A decreasing ratio is a proper fraction. So we are going to multiply by 4 over 6. 4 over 6 because it's a decreasing ratio, so it's a proper fraction. 4 over 6. Now this is what we're going to do. Now let's do it. Let's start cancelling. Let's cancel 6 here by that 6. Let's cancel 4 here, 1. Let's cancel 4 here, 6. Now we have here we have 1 times 90 times this. We have 90. And down here we have 1 here, and then we have 6. So we have 90 divided by 6. If you divide 90 by 6, you get 15. 90 divided by 6 is 15. So our answer is 15. We write here we will need 15 tailors. I think the ratio method is simple. It makes a lot of sense. Embrace the ratio method.